Every space mission, no matter how big or small, advances space exploration. Launched from the International Space Station in February 2020. This is Argus 2. It may not be a large spacecraft, but it has a large-scale objective. It's a 4-inch by 8-inch CubeSat, a small satellite. It weighs 6 pounds. Ground Zero is the Space Systems Research Laboratory led by Michael Swartout, Associate Professor of Aerospace and Mechanical Engineering.
Argus 2 was part of the second activity where we got sponsored by NASA. So we build the satellite, and if we build the satellite and it works and it does what it says it's going to do, then they will fly it.
Argus 2 carried a commercial SD memory card to test the effects of space radiation on data storage. The importance of SD card research is for a greater mission, SLU's next space project.
The next mission, which is called DORRE, Distributed Observation, Reaction, and Response Experiment, is first of all going to be about 4 years of our lives. And probably when it's all done, we're probably going to end up having spent $600,000 on this mission.
DORRE is the constellation of spacecraft and ground systems autonomously working together. It's about the creation of artificial intelligence for space exploration.
Autonomous software has to discover something that it was not expecting. And when there's something new happens, they be able to recognize that it's new and it's interesting and to stop what they're doing and go do that.
The launch of Argus 2 had drawn excitement, but in the weeks that followed, excitement turned into disappointment. They lost contact.
Check in about once a month to try to, maybe something turned on or the antenna is deployed. But so far, we've had radio silence.
It's another setback after Argus 1.
Argus 1 went into the ocean because of a rocket failure.
SLU students are learning from possible complications of Argus 2 as they move forward with DORRE.
In the hassle of trying to get, you can imagine all the wires and everything plugged into a space this big, it's very possible that something got bent or broken or, loosened so that when we go through the launch environment, it shook loose. And so one of the things that the DORRE team said is we're not going to try to squish this into a 1U. We're going to fill the entire tube.
It'll be larger with a new configuration of parts. Partnering with Bennett Research Technologies in St. Louis, DORRE will have sensing capabilities for autonomous exploration.
What we're trying to show is that with very cheap, very simple spacecraft, we can do an interesting mission.
Identifying natural events from space is an example. It would be designed to detect anything at all that may be out of the ordinary.
The actual success of DORRE is it will be listening for radio signals. We will be building a radio map of the world. And what we're going to do is one day it's going to fly over St. Louis and we're going to blast it with our own, we have an antenna on the roof. We're going to blast it with our own radio signal that it's never seen before. And it's supposed to say, oh, wow, that's interesting. That's new. I never expected that. I'm going to take data on that and I'm going to tell my friends, who are then going to turn around and start listening at that frequency in that direction to see if they can figure out what that is.
That's the appeal of DORRE, moving forward in a competition funded by the Department of the Air Force. Winners will be awarded the full $600,000 in August. The SLU team is still trying to solve the lost in space SD card problem.
If this SD card solution doesn't work, then our $600,000 mission is probably more like a $2 million mission because of how expensive it will be to fly more space-rated, space-ready electronics.
No matter what happens, he says the one DORRE spacecraft being built now will fly. As far as the rest,
either the Air Force is going to fund us to build ideally 4 more, or we will figure out a different way to get funding and projects for students to work on.